Hello students, welcome to today's mathematics session. Let us begin the class with the new chapter Cubes and Cube Roots. Let me begin this chapter with a small story. There was a story about one of India's great mathematical genius, Sir Srinivas Ramanujan. Once another famous mathematician called Professor G.H. Hardy came to visit Ramanujan in a taxi whose number was 1729. While talking to Ramanujan, Hardy told that number is a dull number. Ramanujan quickly pointed out this number, that is 1729, and said that it is something interesting. He said that it is the smallest number that can be expressed as a sum of two cubes in two different ways. That is, 1729 is equal to 1728 plus 1, which is equal to 12 cube plus 1 cube. And another way is 1729 is equal to 1000 plus 729, where 1000 is a 10 cube and 729 is 9 cube. So even now 1729 is known as Hardy-Ramanujan number. Even though this feature of 1729 was known more than 300 years before Ramanujan. Then how did Ramanujan know this? Yes, well, because he loved the numbers all through his life. He experimented with numbers. He probably found numbers that were expressed as the sum of two squares and sum of two cubes also. So let us learn many more interesting patterns of cubes, cube numbers and cube roots, and many other interesting facts related to cubes. In geometry, a cube is a solid figure where all edges are equal and are perpendicular to each other. For example, if I take a cube of unit side, if we arrange these cubes to form a bigger cube of side 3 units, then we find there are total 27 such unit cubes. So here we can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the first layer we have 9 cubes. Similarly in the second layer we'll have 9 cubes, and in the third layer we'll have 9 cubes. Then 9 threes is 27. So 27 such small cubes makes up a big cube of units 3. Similarly, if I go with the 4 units, we'll have a 64 such units cubes. So here we came across 9 into 3 equal to 27, where 9 can be expressed as 3 into 3 equal to 27. This 9 can be written as 3 into 3, and this 3 as written as it is, where the 3 is repeating 3 times. It can be abbreviated as 3 power 3 equal to 27. So this power 3 is said to be a cube of number. That is, 3 cube is nothing but cube of 3 is equal to 27. So in the similar way, if I take a natural number m, which can be expressed as n cube, where n is also a number, then we can say m is called the cube number of n. If a natural number m can be expressed as n cube, where n is also a natural number, then m is called the cube number of n. For example, 27 can be written as 3 cube, where 27 is nothing but m, and which can be expressed in terms of n cube, that is 3 cube, where n is also called as a natural number, that is 3 is also called as a natural number. Then m, that is 27, is called the cube number of n, that is nothing but 3 cube. Or in the other way also it can be said, the cube of number is product of a number multiplied by itself for 3 times and is read as the number raised to the power 3. For example, 1 into 1 into 1 is nothing but 1 power 3, which is nothing but 1. Then 2 into 2 into 2, which is nothing but 2 cube, and its value is 8. Then 3 into 3 into 3 equal to 3 cube, and its value is 27. Then 4 into 4 into 4 equal to 4 cube, and its product is 64. 5 into 5 into 5 equal to 5 cube, and its product is 125. Then 6 into 6 into 6 equal to 6 cube, and its product is 216. 7 into 7 into 7, nothing but 7 cube, and its value is 343. 8 into 8 into 8 equal to 8 cube, and its value is 512. 9 into 9 into 9, 9 cube, and its value is 729. Then 10 into 10 into 10 can be written as 10 cube, and its value is 1000. So here you can see the number multiplied by itself for 3 times is called cube of a number, and we are going to read it as 1 power 3. Number power 3, that is a number raised to the power 3. Now the doubt arises, then how to find whether the given number is a cube of any positive integer or not? Yes, this can be found by using prime factorization method. Let me give here one example, that is 1323 is a perfect cube. If it is a perfect cube, then whose cube is 1323, that is 1323 is. Then we need to go this with doing prime factorization by using the prime numbers as we discussed in the square and square root chapter. So 3 4s are 12, 1 remains, 3 4s are 12, 3 1s are 3. The next, again I'll go with the 3 table, 3 1s are 3, 3 4s are 12, then 2 remains, 3 7s are 21. I'll go with the 7 table, 7 2s are 14, 7 1s are 7. Again I'll go with the 3 table, 3 7s are 21 and 7 1s are 7. So here 1323 can be written as 3 into 3 into 3, which is for 3 times, and 7 factor is of 2 times. So here 1323 is equal to 3 power 3 into 7 square. We can see here the factor 3 is repeating 3 times, whereas the factor 7 is repeating only for 2 times. To be a perfect cube, it should have a factor, a number multiplied by itself for 3 times. But here we have 2 times. Therefore, clearly I can say that 1323 is not a perfect cube. Then how to write here? Here factor 7 is not in cube. Therefore 1323 is not a perfect cube. So now coming across the definition of cube, let us learn properties of cubes of numbers. Let us now keep numbers, natural numbers from 1 to 10 in the mind, and let us know the properties of it. Okay, the first property is the cube of an even number is always even, whereas the cube of odd number is always odd. We can observe here 1 is a odd number. If I make it its cube, then the product is again a 1. If I go with the 3 is an odd number, its cube is 27. If I move with the next odd number 5, that is 5 cube is equal to 125, which is also a odd number. Then if I go with the even number, 2 is an even number, then its a cube equal to 8, which is also an even number. The another even number 4 cube, the answer is 64, which is also an even number. So by knowing this, we can say that the cube of even is even and the cube of odd is odd. It was also satisfied even in the square and square root chapter, that is square of even is even and the square of odd is odd. In the similar fashion in the cube of even is even and the cube of odd is odd number itself. So coming across to the second property, the cube of any multiple of 2 is always divisible by 8. So if I go with the 6, which is a multiple of 2. 6 is a multiple of 2 and its cube is 216, means the 216 is always divisible by 8. Similar way, if I go with the 4 is a multiple of 2. If I check with 4 cube, its answer is 64, which is also divisible by 8. Similar way, if I go with the next even number, that is 12, after 10 the next even number 12, if I check its a cube, we get the answer is 1728, which is also divisible by 8. So the cube of any multiple of 2 is divisible by 8. For example, if I go with the 4 cube, that is 4 is a multiple of 2, its cube is 64, which is divisible by 8. If I go with the 6 is a multiple of 2, its a cube, 6 cube is nothing but 216, which is divisible by 8. So similarly, if I check with the cube of any multiple of 3 in place of 2, if I go with multiple of 3, it is divisible by 27. The cube of any multiple of 3 is divisible by 27, because we know that 3's cube is 27. So if I go with the example 9 cube, 9 is a multiple of 3, right? So 9 cube is 729, which is divisible by 27. Similarly, if I go with 12 cube, because 12 has a factor of 3, so 12 cube, its answer is 1728, which is divisible by 27. And keep remember children, 12 is also having the factor 2 and also having the factor 3. Therefore, it is divisible by 8 and also it is divisible by 27. The most important point in the next is the cube of a negative number is always a negative. The cube of negative number. The cube of negative number is always negative. But this was not satisfying in the square, because there we say that the square of negative number is always positive, whereas here the cube of negative number is always negative. Let me give one example here. If I take -3, it's a cube. We know that -3 cube can be written as -3 into -3 into -3, which is nothing but -27. So we got a cube of negative number. Cube of negative number is always a negative. So let me move to the next point. Then what about the cube of positive number? Yes, the cube of positive number is always positive. The cube of positive number is always positive. For example, plus 3 whole cube. So plus 3 can be written as how many times? 3 times because of power 3. Then plus 27. So we'll go with the next point. Point number 6. The cube of a rational number is equal to the cube of its numerator divided by cube of its denominator. So let me take the example here. 4 by 5 whole cube. That is nothing but 4 cube by 5 cube, which is nothing but 64 divided by 125. Or we can write it as 4 by 5 whole cube is nothing but 4 by 5 into 4 by 5 into 4 by 5. We are aware of multiplying fraction with the fraction, right? That is numerator with the numerator, denominator with the denominator. Then I can write 4 cube divided by 5 cube, which is nothing but 64 by 125, that is 125. Or you can write directly, children. 4 4s are 16, 16 4s are 64, 5 5s are 25, 25 5s are 125. So this is all about the properties of cubes of numbers. So let us move with the first worksheet solving, children. Worksheet 1. Find the cube of. Keep remember, children, here is asking cube of number 8, 13, 17, 1.3, 0.06, 0.4, 2 by 3, minus 7, minus 9 and minus 12. So there are total 10 sub questions. In this I am going to solve only 5 questions and remaining 5 you need to solve it, children, as a homework. So solution. First one. What is asking? Cube of 8, that is 8 cube is nothing but 8 into 8 into 8, which equal to 512. Next is fourth one, that is 1.3 cube. Here the given question is cube of. So when you are writing 1.3, don't write only 1.3, children. You need to write 1.3 cube because the question is just cube of a number. So 1.3 into 1.3 into 1.3. So first you multiply number, that is 13 into 13 into 13. So which is nothing but 2197. But after point, one number, one digit, after point, one digit, after point, one digit. So 1 plus 1 plus 1 is 3. So 3 from the right side, leaving 3 numbers, you have to make the decimal point. So the answer is 2.197. Next, moving to fifth one, 0.06 cube. Nothing but 0.06 into 0.06 into 0.06. We know that 6 cube is 216. But here after digit we have 2, after decimal point we have 2 digits, after decimal point 2 digits, after decimal point 2 digits. So 2 plus 2 plus 2 is nothing but 6. But here we have only 3 digits. Don't make the zeros towards the right side because its meaning changes. So you have to make the zeros before a number. So 0, 0, 0, 0. Right? So 6 digits means 1, 2, 3, 4, 5, 6. So the answer is 0.000216. So moving to next question, that is seventh one, 2 by 3 whole cube. As it was expressed in, told in the last property, that is 2 cube by 3 cube. So 2 cube we know that 8, or you can write it as 2 into 2 into 2. And the 3 cube can be written as 3 into 3 into 3, or simply directly you can write its answer is 27. Further cancellation is not possible, right, children? So we'll go with the ninth question, that is minus 9 whole cube. As we have discussed in the property, that is cube of negative is nothing but a negative number. So minus 9 into minus 9 into minus 9, which is nothing but minus 9 cube is 729. Is it clear? So now moving to the second main from the worksheet, which of the following numbers are perfect cubes? To check whether the given number is a perfect cube or not, we have only one method, that is prime factorization method. After doing, we have to see the factors whether they are in triples or not. If their factors are in triples, all the factors are in triples, then the given number is a perfect cube. If any one factor is not in triple, then I can say the number is not a perfect cube. So here in this main we have 5 sub questions, children. I am going to do only the 3 sub questions, that is question 1, question 4 and question 5. Remaining 2 sub questions you need to do by yourself, students. Is it clear? Now let us move to the solving the question. So considering the number 4096, since it is ending with the digit 6, I'll go with the 2 table. 2 2s are 4, 0, 2 4s are 8, 1 remains, 2 8s are 16. Next, it is ending with 8 in the units place, so again I'll go with the 2 table. 2 1s are 2, 0, 2 2s are 4, 2 4s are 8. Again in the units place ending with even number, we'll go with the 2 table. 2 5s are 10, 2 1s are 2, 2 2s are 4. Then again with the 2, 2 2s are 4, 1 remains, 2 5s are 10, 2 6s are 12. Again 2 1s are 2, 2 2s are 4, 2 8s are 16. The next 2 6s are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4. So I have 32 now. 32. You need to continue here only, children. 2 1s are 2, 2 6s are 12, 2 8s are 16, 2 4s are 8, 2 2s 4 and 2 1s 2. So here 4096 can be expressed as, here we can see the factors 2 are in triples. Here the factors 2 are in triples. Here 1 and here 2. So this 1 with this 2 makes a triple and this 2 makes a triple. So I can write it as, so here the factor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So factor 2 is repeating 12 times, which is expressed like 2 into 2 into 2, 12 times. Then looking into the triples, these 2 3 times makes 1, these 2 3 times makes 1s, these 2 3 times makes 1, these 2 3 times makes 1. So I can write 2 cube into 2 cube into 2 cube into 2 cube, which is nothing but 2 into 2 into 2 into 2 whole cube. We know the exponential 2 cube into 2 cube into 2 cube into 2 cube. All the bases are put within a bracket and cube is written in the whole power 3. So the answer is 4096 is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16. That is 16 cube. Yes. Yes, 4096 is a perfect cube. Perfect cube. If the question is asked whose perfect cube, then you need to write 4096 is a perfect cube of 16. So let us move to the next question, that is fourth question, minus 27000. Minus 27000. When you are solving the prime factorization, no need to consider the negative, children. We can put it at the last. Clear? So again I'll go with the 2 table. 2 1s are 2, 2 3s are 6, 2 5s are 10, 0 0. Then 2 6s are 12, 1 remains, 2 7s are 14, 1 remains, 2 5s are 10, 0. Again I'll go with the 2 table. 2 3s are 6, 2 3s are 6, 1 remains, 2 7s are 14, 1 remains, 2 5s are 10. Since it is ending with 5, I can go with the 5 table or I can check with the 3 table. 3 plus 3, 6, 6 plus 7, 13, 13 plus 5, 18. So I can go with the 3 table also. 3 1s are 3, 3 1s are 3, 3 2s are 6, 1 remains, 3 5s are 15. 3 table, 3 3s are 9. 10, 11, 2 remains, 3 7s are 21, 1 remains, 3 5s are 15. The next 3 1s are 3, 3 2s are 6, 1 remains, 3 5s are 15. Hope 5 plus 2 is 7 plus 1 is 8, doesn't comes in 3 table, ending with 5, so I'll go with the factor 5. 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So minus 27000 can be expressed as minus, open the bracket, and 2 3 times into 3 3 times into 5 3 times. So all the factors are repeating 3 times. Then I can say that it is a perfect cube. Minus 27000 is nothing but minus of 2 into 3 into 5 whole cube. Then minus 27000 is nothing but minus of 3 2s are 6, 6 5s are 30. And we know that cube of negative is negative and cube of positive is always positive. Then I can put this minus within a bracket and write it's a cube. So I can write here, yes, minus 27000 is a perfect cube. So let me move to the next question. The next question asked is fifth one, that is minus 64 divided by 1331. So minus 64 by 1331. Then find the 64 factor, even number, so I'll go with the even, that is 2 3s are 6, 2 2s are 4, 2 1s are 2 6s are, 2 8s are, then 2 4s are, 2 2s are, 2 1s are. Next to 1331, it doesn't have a factor 2, 3, 5 and 7. So next prime number is 11. So I'll go with the 11. 11 ones are 11. 2 remains. 11 twos are 22. 1 remains. 11 ones are 11. Again I'll go with the 11 table. 11 ones are 11. 1 remains. 11 ones are 11. Then 11 ones are 11. So this minus 64 can be written as 2 cube into 2 cube. So here the factors are in triples. So it is a perfect cube. Then minus, I can write 2 into 2 by 11 whole cube. Then minus 2 2s are 4 by 11 whole cube. We know that cube of negative is negative. So minus 64 divided by 1331 is nothing but minus 4 by 11 whole cube. Yes, minus 64 by 1331 is a perfect cube. But keep remember children, when you are doing the exam, second question and third question, I will tell the answer. These two are not a perfect cube because the factors will not be in triples. So if the factors are in triples in the sense the factor should be repeated in 3 times. If the factors are in triples, then only it will be a perfect cube. Even if a single factor is not in triple, directly you write down that the number is not a perfect cube. But show that the prime factorization whether the factors are in triples or not. Hope this is clear children. Now let me move to third main. Find the smallest number by which 2560 must be multiplied so that the product is a perfect cube. Again we need to check whether 2560 is a perfect cube or not. So it can be done only with one method, that is prime factorization method. This is same as what you have done in the previous chapter, that is square and square root. So here the number he asked is multiplied. Means directly 2560 is not a perfect cube. But you need to find that number. If I multiply with 2560, it becomes a perfect cube. I'll go with the 2 table. 2 1s are 2 2s are 2 8s are 0. 2 6 are 12. 2 4s are 8 0. Even number again. I'll go with the 2. 2 3s are 6. 2 2s are 4 0. 2 1s are 2 6 are 12 0. 2 8s are 16. 2 4s are 8 0. 2 2s are 4 0. 2 1s are 0. 2 5s are, then 5 1s are. Then here I can write that the factors of 2560. So here the factor 2 is repeating 3 times. The factor here 2 is repeating 3 times. Here also the factor 2 is repeating 3 times, means 2560 can be written as 2 cube into 2 cube into 2 cube into, there is one more factor 5 which is repeating only one time, which is there only for one time, means what is that number should be multiplied. If I want this 5 in 3 times, the 5 another 2 5s are required to become into a perfect cube. Therefore here factor 5 is not in triples. Triplets. Therefore, how many 5s you required? Still 2 more 5s, that is 5 into 5, which equal to 25. 25 must be multiplied to 2560 to become a perfect cube. Hope this is clear, children. That is 25 must be multiplied to 2560 to become a perfect cube. So let me move to fourth question. Find the smallest number by which 8788 must be divided, means it is not a perfect cube, so that the quotient is a perfect cube. So after dividing this with some number, then the quotient we get, that is the perfect cube. So here let us find the factors of 8788 first. Same as the previous question, but in the previous question it is asked what is that number should be multiplied, but in this question he is asking what number should be divided to the given number so that the quotient becomes a perfect cube. So since it is an even number, I will go with the 2 table only, children. 2 4s are 8, 2 3s are 6, 2 9s are 18, 2 4s are 8, 2 table, 2 2s are 4, 2 1s are 2, 1 remains, 2 9s are 18, 1 remains, 2 7s are 14. Then check with the 3. 9 plus 7, 16, 17, 18, 19 doesn't comes in 3 table, children. Go with the next factor, next prime number 5. To go with the next prime number 5, it should end with 5 or 0, so it is not possible here. Then next prime number after 5 is 7, so 7 3s are 21, 7 1s are 7, 2 remains, 27 doesn't comes in 7 table. So it doesn't have a factor of 7. Next prime number is 11. To check with the 11, 11 1s are 11. So here remains 10, 11 9s are 99. Then 10, 1 or 7 doesn't comes in 11 table. So let me go with the 13. 13 1s are 13. 13 6s are, 13 9s are. Then 13 1s are 13. 13 3s are. Then 13 1s are. So here 8788 can be written as 2 square into 13 cube, because 2 is repeating only 2 times whereas 13 is repeating 3 times. So I can write here 2 is not in triplets. So both the 2's should get vanished, means 2 square, which is nothing but 2 into 2 equal to 4. This 2 power 2 should get vanished so that it becomes a perfect cube, which equal to 4, which implies 8788 must be divided by 4 to get a perfect cube. So 8788 divided by 4, which equal to 4 2s are 8, 4 1s are 4, 3 remains, 4 9s are 36, 2 remains, 4 5s are 20, 4 6 are 24, 4 7s are 28. So I got the quotient 2197, which is a perfect cube. So 2197 is a perfect cube of 13 children here. So this is cleared. He asked only the quotient is a perfect cube and he didn't ask whose perfect cube it is. So you need to stop till here only. If it is asked whose perfect cube, then you need to write 2197 is equal to 13 cube. Clear? So let me move to the next main. So fifth main, write true or false for the following statements. The first statement is 650 is not a perfect cube. So before saying whether it is true or false, let us come across the natural numbers cubes from 1 to 10, which was written in the previous. That is 1 cube is equal to 1, 2 cube is equal to 8, 3 cube is equal to 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729, 10 cube 1000. So know it here, children. We have 1 in the units place. Again it ends with 1 in the cube number. If I have 2 in the units place, its cube is 8, means 8 in the units place. 3 cube is nothing but 27. So if the digit is 3 in the units place of cube number, then its product ends with the 7. If a number 4 in the units place, then its cube ends with 4. 5 cube in the 5 in the units place, it ends with 5. So 5 with 5, 4 with 4, 3 with 7 and 2 with 8. Then if I come across with 6 cube, 6 in the units place, then the digit ends with 6 in the units place. 7 cube is nothing but 343. So 7 and 3 are mutually interchanging. If a digit in the 7 in the units place, then its cube ends with the 3 in the units place. Whereas 3 in the units place, its cube ends with the digit 7 in the units place. So 8 cube 512. Whereas if units place is having 8 and its cube ends with the digit 2. Whereas 2 in the units place, its cube ends with the digit 8. This should be known, children. And 9 cube, 9 again ends with the 9 only, children, in the units place. Whereas 10 cube is nothing but 1000. If you have 100 cube, then we can write 100 into 100 into 100, then 1 followed by 6 zeros. So whenever you want to say whether the digit is, the number is a perfect cube or not, when it ends with the zeros in the units places, units, tens and hundreds places, you need to check whether they are odd number or not. If they are odd, how they are odd? So if they are ending with the multiples of 3 zeros, multiple of 3 table zeros, then we can say the given number is a perfect cube. So here I have 10 lakh. 10 lakh is a perfect cube because it is having 6 zeros. 6 zeros is nothing but multiple of 3, that is 3 2s are 6. So 100 cube is nothing but 10 lakh. If it is ending with 1 0, 2 zeros in the units place, in the places, respective places, then directly we can say it is not a perfect cube number. So now solving the questions in the fifth main, 650 is not a perfect cube. You can see it is ending with 1 0, means directly I can say the statement is true because he said that it is not a perfect cube. Yes. Then second question, perfect cubes may end with 2 zeros. So just now we have discussed if they are ending with 1 0 or 2 0, it is not a perfect cube. So the statement is false. Next, third question, perfect cubes of odd numbers may not always be odd. So according to the properties of cubes, we have learned that perfect cubes is nothing but cubes of odd numbers. But here he said always, may not always be odd. So the statement is false here. It is always odd, not may not always be odd. Okay. Next, cube of negative number are always negative. Yes. We have learned just now, cube of negative number is negative and cube of positive number is positive. Now for the fifth question, for a number to be a perfect cube, it must have prime factors in triplets. No need, children. It is false. If we go with the prime numbers, then we can say it should be triplets. So for example, here I can give 216. 216 is nothing but 2. It can be written as 2 cube into 3 cube, or directly I can write it is nothing but 6 cube. So 216 can be written as 6 cube, or 216 the factors can be written as 2 cube into 3 cube, which is nothing but 6 cube only. But here the question is given, for a number to be perfect cube, it must have prime factors only. But we know that 6 is not a prime number. So it can also be expressed in prime factors and also cannot be expressed in prime factors. But keep remember, it should have triplets. That's all. Clear? So according to this, the statement is false. So this completes first worksheet, children. So in the next class, in the next concept, with the next concept. Thank you, children. Have a nice day. Thank you.